The next part of this chapter is about risk analysis in capital budgeting. It is about dealing with uncertainty about a project's future probability. And we're going to develop the standard deviation of the project NPV and the standard deviation of a project IRR and the beta, which is a correlation between one variable and the NPV. In this risk analysis, we first need to know whether certain variable would have an impact on the NPV. So let me just use NPV as the only one we're analyzing here. Forget about IRR. While we can do the same analysis with IRR, but for saving time, just focus on NPV now. I just pick up this price variable, so 200 here as it is given. And if I do some change to this price, definitely my NPV would change. Since I will need to keep showing you how price change would affect NPV, and I don't want to scroll up and down, that is quite annoying, I will hide this area of Excel, not delete it, but just hide. I will use the group function here, all right, just hit group, and then you will see two buttons show up. This is the expanded view, and this is the shrink view. So what you see here is a price and NPV. So if I change the price to 300, and you will see my NPV gets enlarged, it's because all the sales will change accordingly when my sales increases. All right. And if I change the price to 100, then my NPV would be reduced accordingly. Let me just recoup that. And if my salvage value changed to 20,000, so what would happen to my NPV when I sell the machine for less amount? Then my NPV would be reduced. Okay. So it is pretty straightforward to know the relationship between a variable like the price here and the salvage value there and the NPV, how they could affect the NPV. But we need to know what would be the quantitative effect on the NPV. So I'm going to use the data table, and I will develop certain percentage changes for the sales. So let's say change of sales, and I will use a negative 30%, 0%, positive 30%. Okay, and then I will need to find out what will be the NPV when the sales change by this much. I'm going to link this sales right below it to the NPV outcome in my previous work. And I need to replace these percentages into one cell in order to get the corresponding NPV in the cells below. So that one cell is 0%. I put it here. It could be anywhere else. It does not really matter. Okay, what really matters is I'm going to connect this 0% to my price. Okay, to my price. So I will use a 200 multiplied by 1 plus 0%. Previously, it was just a given number, no formula, but here I actually changed it to a formula connected with this 0%. So if I change 0% to 30%, then everything would change. I would get a different NPV, and this 233705 will be recorded here. And if it's 0%, then the original NPV will be recorded here. If it is a negative 30%, then the new negative NPV will be recorded here. Okay, just get back to 0%. I'm going to use the data table function of Excel. So I will select all the area, including this borrowed NPV. That's very important. Okay, and hit what if analysis. It's under the data tab. I will hit data table. All right, since all the percentages are in a row, I will choose a row input cell instead of a column, and I will just simply hit this 0%, and that's it. That's the only thing you need to do. Then hit OK. Okay, as you can see, once the data table is completed, I would have a different NPV under each of these percentage changes of the price or the sales. Okay, and I can do the same thing with the change of a salvage. And once again, I can make the percentage changes. This time I'm gonna make it a little fancier. So -30, then -20, just to make more numbers, and I can generate more NPVs. And I will still do the same work, and the Excel would just do all the calculation for me. And for the cells below that, I will borrow the NPV. All right. And for the salvage, right here it is a given number, 25,000. As you can see here, the formula bar shows only a number. And I will put a 0% somewhere and link this number to the 0%. By doing that, I have to change the number to a formula multiplied by 1 plus the 0%. Okay. From the view, it does not really change anything once I replace the number with a formula, but it does have a significant effect on my data table operation. So I'm going to select all of these percentages and do the same old trick, data table, and do the row input cell, just hit this 0%. So the whole idea here is to use each of the individual percentage right here to replace the 0% and then record the final NPV output underneath. And I'm going to do this process 7 times, relying on Excel. Okay, so here are my output. Decrease decimal. Okay. All right, so what's the point here? Why does it make sense? Because we want to know between the two variables or among a bunch of variables, maybe 10 variables, which variable is the single most important variable that affects the project profitability? Okay, which one is the most important one? If we compare sales and salvage, which one will be more important? It depends on which one would have a larger effect on the NPV when this variable change by the same amount of a percentage. Okay, so if I plug them into a chart in your PowerPoint, it actually shows you the shape of the chart. You can see the unit sold here, salvage, but here I really want to work on the price. So I will insert the scatter chart with straight lines. Okay, and select data, add a series. This is called changes of the sales. The x values are the percentages of the variable. The y values would be the NPVs. So 3 x's and 3 y's. So change of the sales would have a pretty strong effect on the change of NPV. And then on the same chart, I will add another series, and this time it's called a change of a salvage value. And x values would still be the percentages, even though I have 7 data points instead of 3, but it just shows the same shape of a chart, same shape of a curve. And the y values, again, would be the NPV. Okay, so right here, as you can see, the chart shows you how the change of a price will affect the NPV. So that's a pretty steep line. And the change of salvage, which does not really affect your NPV because the curve is really flat. That means for a large change, let's take a look at this orange curve. For a large change of the x value, the y value would change by a slight amount, very little amount. Okay, so if you have this limited amount of attention and focuses or energy and money, you should focus on boosting the selling price or the sales of the project instead of focusing on the salvage value, how to sell more for the same machine. Okay, so that's what the sensitivity analysis is about. And in your assignment 4, you're going to conduct the sensitivity analysis, and you will follow my instruction step by step. And in the PowerPoint, it shows you three variables. One is R, which is a cost of capital. Another is a unit sales, which is the number of units. So if you look at the data, it's basically this unit sales right here, and the salvage value right here, and the cost of capital right here. They are analyzing three variables. And for the base level change, when each variable changed by negative 30%, so this is how the NPV would be at the outcome. If each variable changed by negative 30%, what would be the corresponding NPVs? And then eventually we're going to plot each of these variables a relation with NPV on the same chart. So we have three relationships indicated by three lines or three curves. The steeper ones indicates more importance, more influence on the NPV, on the profitability or the desirability of the project. And the flatter ones basically are not important ones. So you should know where to focus on in order to boost the performance of the project. So that is about sensitivity analysis. So the next one is scenario analysis. The scenario analysis have very limited scenarios, usually 3 or 5. It gives you the worst case, most likely case, best case, and in some other questions I would ask for the below average and above average, just added another 2 cases here. And each case comes with a certain probability. So you have the best case comes with a 25% probability, the worst case comes with a 25% probability, the base case comes with a 50% probability. Okay, you will need to calculate the corresponding NPV for each of the cases. In the best scenario, why do we call it best? Because we sell more units and each unit is sold at a higher price. Why we call it a worst case? Because we sell less units and the price per unit is lower. So I can verify the result here. So for the unit, I can make it equal to 1600. Okay, they all equal to the 1600. And for the price, in the best case, is 240. Okay, and it increased by 3% in the next years. So what will be my finalized NPV is 278,939. So which is consistent with the result here. And if I do the worst case, so the units sold is 900. It's actually units, sorry. And the price here is 160. And then my outcome would be negative 48,000 for the NPV, or 49,000 if I round it. So you will have different corresponding NPVs under different probability. And based on this data, you need to calculate the expected NPV and the standard deviation of the NPV. This is something we learned in chapter 6, the risk and return. So you have the probability and you also have the output. So how exactly can you do it? So let me just put in the probability here. And for the NPV, 279, 88, negative 49. All right. So how do you get the expected NPV? It is just a sum product of the probabilities and the NPVs. All right. Because I use a vector of Excel to do the calculation, I need to hit Control Shift Enter. Okay, Control Shift Enter all together. So this is my expected NPV. And what about the risk level or the standard deviation? Well, standard deviation is a different animal. Since we have all these probabilities playing a role, we can't treat each of these NPVs equally. There's no given Excel formula to solve for that. In order to solve for this standard deviation, we will need to use different formulas, but we can combine these different formulas into one formula, and we need to follow the mathematical formula for it. So the standard deviation basically is a square root of a variance. And the variance is the sum of products of square deviation multiplied by the probabilities. So what would be the square deviation? What is deviation? It is each of this NPV outcome minus the expected NPV. That's called a deviation. So I will select all three of them minus the expected NPV. So that means each of the three will be subtracted by the expected. Then I will take the square of it to get the square deviation. And this will be multiplied by the probabilities. This is called a sum of product function of Excel. Okay, so I close the first parenthesis. This is for the sum, and then I close the parenthesis for the square root calculation. Okay, and there's also counter parenthesis here for the calculation of deviation. Then I hit Control Shift Enter. This is the standard deviation of NPV. Okay, so now we know the expected NPV. If it's not too good, if it's not too bad, that's where my NPV gonna be, and it definitely comes with uncertainty. And the standard deviation here is $160,000. So what does that mean? We're going to conduct forecasts based on the expected and standard deviation. The expected and the standard deviation here are estimated based on the existing information. We have the best case and the worst case based on our business information, our analysis of the entire environment. Still, we need to do some mathematical forecast based on this expected NPV and the standard deviation. And we are assuming that the NPV falls into a normal distribution. So normal distribution is a camelback shaped curve with in the middle has higher probability, and at the two extreme it has a lower probability of occurrence. We were going to use the scenarios, not just these three scenarios, not 5 scenarios. We're going to use the computer power to simulate a lot scenario, maybe 100 scenarios, maybe 1,000 or 10,000 scenarios. And this is called a Monte Carlo simulation. And how exactly do I do it? So right here, I have posted a Monte Carlo simulation, and the data is right here. Mean is 10, and standard deviation is 2. And I have generated or simulated like 1,000 observations. Okay, 1,000 observations. So column A shows the number of this observation. All right, and column B shows the value of the observation based on a normal distribution with a mean of 10 and standard deviation of 2. So here is the formula. I put it in here. Let me just zoom it in. Zoom in a little bit. So you can just copy this formula. There's nothing complicated about it. You can just use the formula for your exam or for your homework. When you do that, make sure the mean is in the right place and also the standard deviation in the right place. So this is the same formula we're going to use for the Monte Carlo simulation later. You just need to make sure you put the mean and standard deviation in the right place. So each time I hit enter, you will see the number would change, and all the numbers below it would change. Okay, so after I finish the first one, I just simply drag it down all the way, or just double click on the right bottom corner. The values will be different. Each time the computer will simulate a sample, okay, a random sample based on a normal distribution with a mean of 10 and a standard deviation of 2. So you can see the values here, most of them are closer to the average, and fewer of them are distant from the mean. So how can I tell that? I will generate a I will generate a histogram to show you how these values are distributed. Okay, so the average is 10 and the standard deviation is 2. So let me just insert, and right here you will see the chart, and I want to do the histo chart. Okay, I will need to select first all the values, not the numbers, not their serial number. Select all the values of this randomly generated or simulated values, and then hit insert histo chart. Okay, histogram chart right here. Okay, you can see the Excel simulation did a pretty good job. The shape here is pretty much a normal distribution with the value close to the middle with higher probabilities, and the value remote to the average, like right here and right here, the probabilities are pretty low. Okay, so what's the whole point? Well, the point is we don't want to lose money, right? We don't want to have a project with a negative NPV. And based on this Monte Carlo simulation, based on generating thousands or even thousands of observations, we can calculate how many of these observations are below zero. Okay, how many of them are below zero? For example, in the previous exercise, my expected NPV is 102, my standard deviation is 117. So let me just replace the number here, 102 and 117. So right here you can tell still all the simulated samples falls into a normal distribution shape. And right here, the vertical axis are the probability, are the number of observations, but it's not a probability per se, but from the observation amount, you can tell which one has a higher chance of a probability. For example, this bar right here, this bar are the values falls between 111 to 151. Okay, so if it is 112 or 120, 141, 150, they all fall into this bar, and it has like 140 observations out of 1,000. Okay, like this bar, any values fall between 71 and 111 would be in this bar, and there are about 120 of them out of 1,000. And when do you lose money? Right here, you will see there are certain probabilities of losing money if it is because the value begin to be negative. From negative 9 to 31, you will have this amount of observations with pretty low values. And here the values are even lower, and this is definitely the negative values, the negative NPVs. And here are even lower numbers, more negative, and more negative. And you can do this count. You can count how many of them are negative. You see some of them are positive and fewer of them are negative. And based on the chart, based on this Monte Carlo simulation, you are able to tell how many of the observations would fall below zero. That's the case you lose money, and you will get a probability stating that like 30% of probability or 28% probability the project would lose money. So that's the whole sense, that's the whole idea of the Monte Carlo simulation. Back to the PowerPoint. The Monte Carlo simulation basically is thousands of a scenario analysis. So you see for each scenario, you can replace a number for the units, and you can replace a number for the price based on its distribution, and then you can record the NPV, and this is the expected value, and here is the standard deviation of each of them, and you can get the NPV, and then you will need to calculate the probability of NPV. that are greater than 0. Okay, so this is how we do Monte Carlo simulation in Excel. So we are going to get the two variables. One is units and another is a price. The product of the two will give us the sales. We assume normal distribution for both units and a price. As the PowerPoint says, we are going to generate 2,000 trails. So we are going to simulate the samples 2,000 times. And I have to do this in the same Excel sheet. Otherwise, the data table will not function across a different spreadsheet. So let me first just ungroup the data and group again in order to show a better view. So I want to hide the cells here, okay, and hit button number 1. This is shown, and I want to hide the cells here as well. Group, okay, and then hit button number 1, and I want to hide these ones as well. Okay, so they don't show. Let's say for units, the mean is 1250, and the standard deviation is 199. And for price, the mean is 200, and the standard deviation is 30. And I'm going to simulate 2,000 samples, assuming normal distribution, and it's going to be a random simulation. Let's just first create a column called the serial number from 1 all the way to 2,000. And then I will define for the units and for the price with the function of a normal distribution. You can just copy paste my formula here. I want it to be randomly generated, and I want the mean for units to be 1250, lock it, and the standard deviation to be 199, click it, and then lock it. All right, and for the price, again, is normal distribution, random selection, mean is 200, click and lock, standard deviation is 30, click and lock. All right, decrease the decimal so I'm not looking at too many numbers. Okay, then you can drag it, and I'm going to drag the whole thing down until I have 2,000 samples. Okay, now it's too much. Get back to 2,000 and delete. So once I get a 2,000, that's the end of it. But it really does not matter if you have 100 more of samples generated. So as you can see, each time I do a clicking, all the numbers will change. And if I do a histogram, so just select all of the data here, insert a histogram chart, it goes like this. That looks like normal distribution to me. And I do the same thing for the price. Okay, insert a histogram chart. It looks like a normal distribution as well. All right, so both of them would give me sales. Okay, and the sales would be the unit multiplied by price. Okay, you would agree on that. And I have to be specific. It is the sales of a first year, of year 1. Okay, just a double click on it. $sign, there's decimal. Okay, so now I have generated all the sales, and I will put another column. I will record the NPV because that's the ultimate term I'm looking at. I want to look at whether this project is generating enough profit or not. And I will use the data table function because I really can just calculate NPV 2,000 times within 5 minutes, right? So right here, I will first borrow the NPV at this very specific place. Okay, I want you to remember this specific place. Later on, when I generate the data table, so this would be the area of my data table, and I want the data table to start the NPV at this column in this row. Alrighty, so what I'm going to do next, technically I will replace each of the cells randomly generated into the cells right here, okay, into the cells right here. And right now the setting is 250,000, which is the product of units and price, which is a given number, and I don't want that. I just want it to be 250,000. All right, I just want it to be 250,000. And all the other numbers here in the sales, for example, the second year sale would be the first year sale multiplied by 1 plus 3% inflation. Lock the inflation, please. And then drag it all the way. So instead of using the units and the price here in the rows above in the capital budgeting table, I just bluntly replace the cells here with a solid number, a given number, not a formula. That's how I start my data table operation. Okay, so since this is finished, I will select my entire 2-column data area here. Okay, and then I will hit data tab, what if analysis, and I will do data table. Okay, when I do the data table, this time my input cells, let's say all the cells are here in the same column, not in the same row. So I will select a column input cell here. And for the NPV, actually we don't need to worry about NPV. I just need to replace each of the number to this cell here. So just to click on that, the sales of the first year right here in the capital budgeting table. And then I will do the simulation. Alrighty, now I got all my NPV generated. Select them all. $, decrease decimal. Yeah, I'm pretty happy with my NPVs generated from this operation. Okay, this is called the Monte Carlo simulation, and that's not the end of it. First of all, I need to know the max of an NPV, so I just simply make it equal to the max of all the numbers here. Hit enter. So that's a 473,855. I know the number would be off from the number here, but it's not quite different. Each time when I hit the Excel, it would give me another round of simulation 2,000 times. But right here, you can see the max number is not that different. And then I will get a minimum of NPV. So I just use the minimum function here. Select all the NPVs from the first observation. Hit enter. Okay, so the minimum is a negative 184,000 somehow, which is not very different from the one here in the PowerPoint. And I can also do the median. It is a median of all the NPVs. Hit enter. Okay, that's the median of it. And I can, well, you see, each time I hit something, all the simulation got changed, right? But still they fall into the same irregularity, which is a normal distribution. And I can also count how many of these 2000 NPVs are negative. Okay, so I will generate the histogram. This time I will do the data analysis, and my bin here just use one cutoff point as 0. Okay. Then I do data analysis right here and just close it. So data analysis and then do histogram. And my input would be the NPVs, and the bin here is just this number 0. Okay, it takes time here. Well, there's only one cutoff point, unlike your previous histograms. There are so many cutoff points to make different columns. Okay, so it shows you that among the 2,000 samples, 420 of them are below 0, and 1,580 are above 0. So what would be the percentage for the NPV to be less than 0? So you use the 420 divided by 2,000, and this is a 21%. If we check the PowerPoints, then the negative NPVs would be like 13%, but hey, it's different than simulation. So if I do the simulation one more time, the number definitely will be different. So let me just do it one more time, just do some random thing to change it. And you can see all the numbers here changed. And I will do the what if analysis again. Data analysis again, histogram. Define it. And all the NPVs are in the input range. The bin range is just the 0 input. Hit OK. Okay, this time is the 422. So this is a Monte Carlo simulation.